Hello everyone. In this video we will learn about continuous integration and continuous deployment. We will be hands-on and we're going to set up the infrastructure for our pipeline and configure the entire process. Before we begin, please make sure that you are familiar with the following items on this list. I assume you have a basic understanding of these things, but if you don't have any experience with these items, you can still benefit from this project, because my goal is to simplify things as best as possible. So let's begin. This is a visual representation of the current application that is running in the cloud right now. As you can see, our project or our application is sitting inside of an EC2 instance. For the front end, we have React, and in the back end, we're using Spring Boot, which is a Java framework. We also have Nginx as a reverse proxy handling our routes to the backend APIs. On top of that, we're communicating with an RDS database to help us perform our basic CRUD operations. This is a very simple app. All we are doing is creating a list of books. We can add, delete, and update books. Let's see what the application actually looks like. As you can see, we have the IP address of our EC2 instance that's hosting this application. And it's a very simple application called Book World. I can take any of these books and edit them. I can add books. If I want, I can add another book. Call it Book 3. Author 3. 4.9. 2009. And let's just refresh the page, and as you can see, we've added the book. If we want, we can delete the books, so I can delete this one, and that book is deleted. We can edit the books if we want. So for example, we can edit this one. And as you can see, we've edited the book. As I mentioned previously, I assume you have a general understanding of what CICD is. The idea is that whenever we make changes to our application, we will grab the code from GitHub, build it, test it, and deploy it automatically. This is the architecture that we will be setting up for our CICD pipeline. As you can see, we're using software like Jenkins, Ansible, Nexus, and SonarQube, and I'll walk you through what these services are for, and we're going to actually implement them in our project today. We will need separate servers for Jenkins, SonarQube, and Nexus. So let's quickly go over the process we will go through for this project. We have what's known as a Jenkins file in our GitHub repository. This file lists all the stages of our CICD. When we install and set up Jenkins on our EC2 server, we're going to tell it to go pull the code from our GitHub repo and execute this file. On the right side of the slide, you can see which tools we're going to use for each of these stages. I will talk in more detail about these tools as we move along in the project. We're going to set up the EC2 server that Jenkins will run inside of. But before we do that, we need to have our security groups for the Jenkins EC2 server. Basically, in security groups, we determine what ports are going to be opened and who is allowed inside. Now, I've already set up my security groups, and I assume you have enough experience setting them up. Here are the rules for the security groups for Jenkins. We will open port 8080 of Jenkins for all IP addresses. I'm doing this because we will be using GitHub webhooks, which will be used to automatically send the code of the application to the Jenkins server as soon as a push is made to the branch. SonarQube will also need to connect to Jenkins via port 8080 in order to send the results from the code analysis. Now we're going to allow traffic on port 8080 for both IP4 and IP6 addresses. I also want to be able to SSH into the Jenkins server So I will open port 22 for my IP address. Now that we have our security groups ready for Jenkins, let's go ahead and set up the EC2 instance for it. We're going to call this Jenkins Ubuntu. Most of the time, T2 Micro doesn't really work when you are building and testing your project. So when working with Jenkins, you want to go ahead and use T2 Small or larger. So for our project, we're just going to use T2 Medium. Now I already have an SSH key that I will be using. I assume you know how SSH works and how to set up a key pair for SSH. Select existing security group. Jenkins. Click on Advanced Details. So the user data is basically the script that the EC2 instance will be running when it's being provisioned. We're going to copy and paste the script to install Jenkins over here so that once the server is up and running, Jenkins is already installed. We are going to copy this script right here to install Jenkins. We're going to need OpenJDK 11 and Maven before we install Jenkins. We're going to need the curl command and the echo deb command in order to prepare the packages and the keys that we're going to need to install Jenkins. After that, we're going to update again and then install Jenkins, and then we're going to enable it and start the Jenkins server. So let's copy this into the user data. Launch instance. Okay, this is the one we want. Let's go to the public IP. We want port 8080 and make sure we're using HTTP. This could take a few minutes. Okay, as you can see, our Jenkins server is up and running now. So we're going to need to go and SSH into our Jenkins EC2 instance. Go to this path right here and copy the password from there and paste it over here. I'm going to go on git bash. Let's SSH into the Jenkins server. Get the public IP. Make sure you're in the directory where your SSH key is located. -I. My key is called first AWS private, and then it's an Ubuntu instance, and then paste the IP4 address. Say yes, and now we're inside the Jenkins instance. Let's copy this path right here so that we can see the password. We're going to say cat to display what's inside that directory. Paste. Let's try sudo cat. Paste. And there is the password. Copy it and continue. For now, we're going to say install suggested plugins. This is going to take some time. The next thing we need to do is to go to our security groups for the EC2 instance that is hosting our app. Here is the security group. Now again, this is the security group for the EC2 instance that is hosting our Java application, or our Spring Boot application in the backend and React in the front end. Now, during the deployment of our artifact or the war file, Ansible is going to need to be able to reach our app server via SSH. So that's why we have the security group over here. Now, Ansible is going to be also running inside the same instance as Jenkins. So this is the security group for the Jenkins instance. And the rest of these rules are allowing me to be able to go on that instance from port 8080, port 80, and via SSH on port 22. Now let's come back here for a second and create our username and password. We're just going to say admin for everything. Save and continue. Oops. admin@admin.com. Save and finish. Start using Jenkins. Now that Jenkins is up and running, we're going to need to set up some of the plugins that we are going to need for this project. These plugins are just tools that Jenkins is going to need to do every step in our CICD pipeline that will enable it to communicate with SonarQube and Nexus and do other tasks. Some of these tools are the Maven integration tool that's going to allow us to build and test our project in the CICD pipeline. We're also going to have a way for our Jenkins server to communicate with GitHub. And we're also going to need to build timestamps, which is going to be very important later on when we're uploading our artifact and also retrieving it. So let's go to Manage Jenkins. Go to Plugins. We're going to go to Available Plugins. And we're going to install a few plugins. So let's start with Maven integration. Okay, let's click on that one. And then we're going to need Nexus Artifact Uploader. We're also going to need SonarQube Scanner. We're going to need Build Timestamp. Here it is. We're going to need GitHub integration. And we're going to have to install all of these without restart. Now let's go set up our SonarQube server. Okay, launch instance. We're going to call this SonarQube. We want it to be Ubuntu as well, which is my preferred OS. We're going to go with T2 small. Same key pair. We're going to use an existing security group that I created for the SonarQube server. Let's take a look at this security group. So as you can see, I want to be able to SSH into the server, and therefore I'm going to open port 22 for my IP. I also want to be able to access the SonarQube server from port 80. Now, SonarQube generally runs on port 9000, but as we will see in the script to install SonarQube, we're actually going to also install Nginx server, which will listen to port 80 and direct all the traffic for SonarQube, which is originally supposed to go to port 9000. and that's why we have port 80 listed over here and over here. Now, since Jenkins is going to need to communicate with SonarQube during the CICD process, we're going to establish connection between Jenkins security group and port 80. So that's what this is right here. This is the security group for Jenkins. Now let's go back to our server setup. We're going to say advanced details over here, and then we're going to copy and paste our script to install SonarQube. Let's take a look at that script. Now, as a tip, we can get these scripts from online. If you just look it up on Google, look up install SonarQube, Jenkins, or any other software that you want to install on Ubuntu or any other OS. You can get the commands from the internet. The installation steps can also be found scattered on the documentation for whatever software that you're going to be trying to install. At the top here, we have some lines regarding ulimits, and basically ulimits deal with the resources that each user in the system is allowed to have, the number of resources. For instance, you can put a limit on the amount of processes a user can run or the amount of files that he can make. Here we have to edit the limits.conf file, which has to do with limits and allowing our Sonar user, which we will create very soon, allowing that user to have certain abilities. Here we're going to need to install Java before installing SonarQube. We're also going to need to install Postgres DB. Now, by default, when you install Postgres, a user named Postgres is going to be created, and this user doesn't have a password. We want to give this user a password admin123. The chpassword command needs the username and password to be separated by a colon. Now we're going to create a user called Sonar inside the Postgres database. We're going to create this user as a Postgres user. Now we're going to need to run sudo -i-u to run this command right here, psql -c alter, as the Postgres user. Basically, this is a Postgres command, and in order for us to run this command, we need to momentarily become the Postgres Linux user. The -c command will run one command and then terminate afterwards, so we don't end up stuck in the psql shell for the following commands. After that, we're going to install SonarQube. Now this capital O here, this capital O, is going to download the file with its original name. The -o flag over here, without this flag, you might have prompts which we can't answer since we're running this script, so we want to override those prompts. The -d here is for the directory where you will unzip inside of. Here is the sonar.properties file, and it contains some information that's going to be needed for this setup, such as the username, the password, and the URL to connect to Postgres, and the port. And then here we have the sonarcube.service file, and in this file we specify how SonarQube is going to be started and stopped. After that, we're going to enable SonarQube, and then we're going to install Nginx. And basically what Nginx is going to do, it's going to listen on port 80, and here we have the proxy pass directive, and basically listens to every single route or every single path. And what it does is it listens on port 80, and everything coming to port 80 it's going to send to the SonarQube server. That's why when we're trying to hit the EC2 instance that SonarQube is running on, we don't need to add 9000 to it. We're going to enable and then start the Nginx server, and then hopefully this will be the end of the process. So let's copy all of this and paste it into the user data. We're going to say launch instance. And again, this might take a few moments. Let's go to the public IP of our SonarQube instance. And again, we don't need to go to port 9000. We just need to go to port 80, which is the default port. Alright, it looks like SonarQube is up and running. We'll give it a minute here. Alright, so SonarQube is up and running. So we're just gonna put in admin for everything. Okay, the old password was admin. We need to create a new password. New password, we'll call it sonar. Okay, and we are in the SonarQube dashboard. So let's talk a little bit about what exactly SonarQube does. It's going to take the source code and then provide reports for the code quality of your project. It's going to analyze the code, and then it's going to determine whether there are some styling issues, code duplication, lack of test coverage, or excessively complex code. Now when it analyzes your code, it's going to appear on the project dashboard. You're going to see the name of your project and the score or grade your code received for each category. Those scores are based on what's known as quality gates, which are the standards for whether your code passes or fails the code analysis. Now SonarQube comes with its own default quality gates. For example, if the test coverage is below 80% of the code, then it's going to fail automatically. It's going to fail in that category. You can change this if you want. You can customize the quality gates as you wish to better suit your standards. Now there's a few things that we're going to need to do in order to establish communication between Jenkins and SonarQube. The first thing we're going to do is create what's known as a token in SonarQube so that Jenkins can communicate with it. Secondly, we're going to give Jenkins the SonarQube IP address and token. And then thirdly, we're going to add SonarQube. We're going to add the SonarQube scanner tool inside of Jenkins. So let's do these things one by one. Let's first start off with creating the token in SonarQube. We're going to click here for administrator, and we're going to click on my account, click on security, and then we're going to enter the token name here. We're going to call it Book World Token. And we're going to say generate, and we're going to copy it here. Let's just open up a little notepad and copy it here for the time being. So what we're going to need to do now is go to Jenkins and create the credentials for SonarQube, and this token is going to be needed in that process. So let's go to the Jenkins dashboard. We're going to need to go to manage Jenkins. Let's log back in. Let's go to manage credentials. Let's click on system. Let's click here. We're going to add credentials. For kind, we're going to say secret text. We're going to paste our token here. And for ID, we're going to put SonarQube token. We'll do the same for description. And then we're going to say create. Now what we're going to need to do is give Jenkins the SonarQube IP. Let's go back to the Jenkins dashboard. We're going to say manage Jenkins. We're going to say systems. So we're going to need to scroll down to SonarQube servers and then check off environment variables. SonarQube servers. Check off environment variables. And then we're going to need to click on add SonarQube. For the name, we can type just SonarQube. And the URL is going to be the private IP4 of SonarQube. So let's get the private IP here. Now we're using the private IP here instead of the public IP because every time you stop and start a EC2 instance, the IP address changes. But if both of these instances, the Jenkins and SonarQube, are in the same VPC, then they can communicate via private IP. So we're just going to use the private IP because that doesn't change whenever the instance starts and stops. And then for here, where it says server authentication token, we're going to use the SonarQube token. And then we're going to click apply and save. Next thing we need to do is add the SonarQube scanner. Let's go to manage Jenkins. Let's go to tools. Let's look for SonarQube scanner. We're going to say add SonarQube scanner. For the name, we're going to type SonarQube scanner. We're going to make sure that this is automatically checked off. And then we're going to say apply and save. The next thing we need to do is set up the SonarQube webhook. We're going to use the webhook to let Jenkins know that the analysis is done. There's a step in our Jenkins CICD that waits for the SonarQube server to finish the analysis. Once it is done, the SonarQube webhooks will notify our Jenkins server so we can proceed to the next step in the CICD. So let's go to administrator again. Click on administrator. Click on configurations, select webhooks. We're going to create webhooks. We're going to call it Jenkins. Now we're going to give it the private IP of the Jenkins EC2 instance. HTTP. And then we're going to need the port 8080 after. And then SonarQube web hook. And then we can press create. Now we can set up our EC2 instance for Nexus. So let's go and launch an instance. We're gonna choose Ubuntu. T2 small. Same SSH key. We're gonna click and select the existing security group, Nexus. Let's take a look at this security group. So there are a couple of rules that we want over here. Obviously, I want to be able to SSH into the server. I also want to be able to access the Nexus dashboard from port 8081. Since Jenkins is going to need to communicate with Nexus during the CI/CD process, we're going to allow Jenkins security group on port 8081. The EC2 server hosting our application also needs to download the artifacts from Nexus via port 8081. So here we have the security group for our app server. Let's go to advanced details. And here we're going to copy paste the script to install Nexus. So we're going to make a few directories, and this is going to come in handy later on. This is the URL to install Nexus. We're going to use the wget command to install the package. The $O here is to rename the folder we are going to install. Once this wget command runs, the downloaded zipped folder is going to appear in our current directory. We're going to unzip this new folder in the following commands with the tar command, but our script doesn't know the name of the folder it should unzip. That's why we are going to give it a name with this $O. Afterwards, an unzipped folder is going to be created. Our script is going to capture the name of the unzipped folder. So we're going to set this variable equal to the output of the tar command. Basically, the tar command has an output which is a list of all the files in the folder, starting with the name of the unzipped folder. This is basically what the output would look like. It's going to start with the unzipped folder's name, and then followed by all of the items that are inside of that folder. Now, because this command is in between these tick marks, the output is going to be actually horizontal instead of vertical as we just saw. Basically, each output is going to be its own column. Now here we want the name of the unzipped folder to be the first part of the output that we saw. Basically, this right here. All the stuff before the /. And then here we're going to get rid of the unzipped folder since we don't need it. Our unzipped Nexus dir folder is inside the /temp/Nexus folder. So we will copy our unzipped folder and sync it to the other directory. And here we're going to add a user called Nexus, and that user is going to own this directory. And here we're going to create this nexus.service file. And inside the nexus.service file, we specify how we stop and start the service. And we're going to have this run as user equals Nexus here inside of the nexus.rc file. Afterwards, we can reload the daemon and start and enable the Nexus service. So let's copy all of this here, paste it here. There's one thing that I forgot to mention. Nexus recommends at least 4 GB of disk space. But from my experience, we can run into problems, especially when we are constantly running our CICD process over and over again, which means that we're going to be uploading to the Nexus artifacts over and over. So that can lead us to quickly running out of space. So what I like to do is I like to go up to 16 GB. So that's what we're going to specify over here. We're going to say 16. And then now we can say launch instance. Now it looks like our Nexus EC2 instance is up and running. However, before we proceed, I want to point out 2 mistakes that I made. One is over here, there was another arrow sign, and it's just actually 1. Another thing is that we're using a T2 medium instead of T2 small. Nexus kept crashing due to a memory issue, and I suspected that was due to the fact that we were using a smaller instance. So I switched to a T2 medium. So if you've been following along and you made those 2 mistakes, please correct those. Now let's learn a little bit about what Nexus does exactly. As mentioned before, Nexus is a tool that we're going to be using to store our artifact, or basically our WAR file. There are 3 types of repositories in Nexus. The first is the hosted repository. When we compile our project, we get a WAR file, which is our artifact. We need to store that artifact somewhere for every version of our application, so we can keep track of the different versions and roll back to a previous version when necessary. We're going to create 2 hosted repositories called Maven Release and Maven Snapshot. The difference between the 2 is that when you push to the Bookworld Release repository, it keeps the older version of the artifact, while the Bookworld Snapshot repository doesn't keep the previous one. It only keeps track of the latest version of your application. The second kind is the proxy repository, which contains the link to the remote external repository, where you can download the components or dependencies the application needs. These components are going to be fetched from the remote repository and then cached in the Nexus proxy repository. So that means that subsequent requests for the same dependencies are not going to go to the remote repository. Instead, they're fulfilled from the proxy repository, which will eliminate the network bandwidth and time overhead of retrieving the components from the remote repository again. Lastly, we have the group repository, which will combine between multiple repositories. Since they are all grouped together, this means that your users can rely on a single URL instead of having a URL for the proxy repo and another one for the hosted repo, and so on and so forth. So let's go ahead and set up all of these repositories in Nexus right now. Now this is the public IP for our Nexus instance, and here it is. And when you go to port 8081, that's where Nexus is listening. Now let's try to sign in. So here it says that our user is admin, and the password is located in this directory. So we're going to need to SSH into our Nexus instance and get this password. So let's go ahead and do that. Let's copy it. Okay, and we're in. Now we need to create a new password, and we're gonna make it Nexus admin. Nexus. It's important to save these passwords because we're going to need them when we set up our Jenkins pipeline. Click on Disable Anonymous Access and finish. Let's click on here. Click on Repositories. The first repository we're going to create is our Bookworld release repository. Maven 2 hosted. Bookworld release. Create repository. Next, we're going to create our Bookworld Maven Central repository. This will be the repository that will cache all the dependencies. And we're going to copy the URL into here. And this is from the Nexus documentation. Create repository. Next, we're going to create the snapshot repository. Bookworld snapshot, and we're going to change it to snapshot, and then create repository. Lastly, we're going to create the group repository, where we just take all of the repositories we created and group them into one place. So we're going to add all of the repositories we just created, Bookworld release and snapshot as well, and then create repository. So when we run our CICD pipeline, Jenkins needs to communicate with the Nexus server in order to upload the artifacts to Nexus. So let's go to Manage Jenkins. Credentials. Let's click here. We're gonna click here. We're gonna add credentials. For kind, we're gonna leave it as username with password, and then for scope, we're gonna leave it as global. Username is gonna be admin. Password is gonna be Nexus admin. So for the ID and description, we're gonna say Nexus. So this ID is gonna appear in the Jenkins file as an environment variable called Nexus_login. And the password is gonna appear as Nexus_password. And the username is gonna appear as Nexus_username. We're gonna say create. So now we have a credential for our Nexus server. Now we need to do one quick task that's going to save us a lot of time and headaches. When we build and push our artifacts to Nexus, we're going to label it with the timestamp of when we created the artifact. Now the default timestamp format is going to cause an error for us in the CI/CD pipeline. So let's go and adjust it. So let's go to Manage Jenkins, go to System. So let's go to Build Timestamp. Here we are. So this white space right here and here are going to cause problems for us. So let's modify this format so that this doesn't become a problem. So let's put a hyphen here and a hyphen here. Basically, it's the year, month, day, hour, minutes, seconds. And this is for the time zone. And here is the sample of the build stamp. It's going to basically look like this: the year, month, day, and the time, and the time zone. You might remember that in order to install Jenkins on our EC2 server, we needed JDK 11. Before we set up the CICD for Jenkins, we need to make sure that our Jenkins server has JDK 8 and Maven installed, because we're going to need these two tools inside of our CICD pipeline, mainly the build and test stages. Click on Manage Jenkins, Tools. Click on Add JDK. We need to give it a name that we're going to use in our Jenkins file. Now there are two ways we can install JDK 8. One way is to use the Jenkins dashboard and click on Install Automatically. An alternative way is to go inside of the terminal for the Jenkins server and copy the path to our Java_home and paste it here in the dashboard. So we're going to go with this option. Let's SSH into our Jenkins server. Let's just do a sudo apt update. Okay, let's look for the JDK 8 package. Sudo apt cache search JDK 8. So we need to go with the open JDK 8 JDK, this one right here. Sudo apt install Now, although we installed JDK 8 right now, the version of JDK that's running is the JDK 11 version. Java version. As you can see, we have version 11 running. We need to tell Jenkins to use JDK 8 instead of JDK 11. So let's go ls. So let's copy this right here and go back to the Jenkins dashboard. And we're going to paste it over here. So let's scroll down and add Maven. Add Maven. We're just going to call it Maven. And this is the latest version. And apply it. Just save. So now we're going to create our Jenkins pipeline. There are different ways to build a CI/CD pipeline. we're going to use a file called the Jenkinsfile, which just contains all the different stages of our pipeline. But before we start the creation of the pipeline, we must allow for both Jenkins and GitHub to be able to communicate with each other. To make that happen, we need to do a few things. First, we need to go inside of the Jenkins EC2 server and create a pair of public and private PEM keys. Secondly, we're going to copy the public key and paste it into the GitHub website. And lastly, since we're setting up the CI/CD pipeline on the Jenkins dashboard, during this setup, we're going to specify the private key in the Jenkins credentials. So let's start with the first step and create the public and private keys. Let's go back to our Jenkins server. Let's switch to Jenkins user. First, let's go to the root user and then go to Jenkins SSH key gen. This is going to generate the SSH keys. Enter. Okay, so the public and private keys have been created. This is the public key and it's created inside of this directory right here, and the private key is created inside of this directory as well. So now we need to give GitHub the public key. Let's go to settings. Let's click here, new SSH key. Let's call it Jenkins. Add SSH key. So now let's create our CI/CD pipeline. Let's click on new item. Let's call it book world CI/CD pipeline. Choose pipeline. Okay. So here we're going to click pipeline from SCM. We're going to select Git. We're going to copy this right here. So under credentials, let's click Add Jenkins. Here's where we need to specify the private key. Let's click SSH username with private key. So we're going to put Git for ID, description, and username. We're going to say enter directly. This is our private key. Make sure you are careful when you're copying this. Then click add. Okay, now we can add Git. Now here we need to make sure that Jenkins is able to SSH to the GitHub server. So let's go inside of the Jenkins server and test that out. We're inside the Jenkins server. There's a command from the GitHub documentations, SSH git at github.com. Say yes. And now we can SSH from Jenkins to Jenkins to GitHub. We want to get the code from the master branch. And then for script path, our Jenkins file is at the project path. Click Save. So whenever the code is committed and pushed to our GitHub branch, we don't want to have to manually start the CI/CD pipeline. We want GitHub to automatically trigger the CI/CD process. Let's first double check if our Jenkins server allows access to port 8080 from anywhere. So let's go to security groups. And it allows 8080 from anywhere, IP4 and IP6. So let's go ahead and set up the webhook. Here's the repository. We're going to go to Settings, Webhooks, Add Webhook. Now here we're going to add the public IP for the Jenkins server. Let's go copy it. Jenkins. And it's going to be on port 8080 / GitHub webhook. And we're going to leave these settings as default. So we're just going to say just the push event and add webhook. Now be aware that if we ever stop and then start the Jenkins instance, the public IP is going to change, which means we're going to have to come back here and update the IP for the webhooks. If we don't want the IP to change, we can put a load balancer in front of the Jenkins EC2 and put the URL for the load balancer instead. Or we could just give our Jenkins instance an elastic IP, but both of these solutions are not free. So we'll just leave it the way it is right now. Now let's break the Jenkins file down. Here we have agent any. In scenarios where we have a cluster of Jenkins servers, we want to specify which one will run the jobs. In our case, we'll just say any. So these are the tools that we set up earlier on the Jenkins dashboard when we were on the global tools configurations. We need both Maven and JDK to run our jobs. And these are the environment variables that we're going to be needing for Nexus and for SonarQube. As you can see here, we have the snapshot repo, the release repo, all four of our repos are here, and our credentials for Nexus, and our information for Ansible and Sonar server. And then here is where we have all of the stages in our CI/CD pipeline. The first stage that we have here is the build stage. The SH here means that we are running a shell command. Now you have to be aware that the shell commands are going to be running from the Jenkins workspace directory. Basically, it's a folder inside of the Jenkins server that's dedicated for our workspace, basically for all of the stuff that we're going to be pulling from GitHub, for all of our code that we're going to be pulling from GitHub. The -s settings.xml here means that the dependencies are going to be taken from the Nexus repository as specified in the settings.xml file, and not the external or the remote repository as we discussed earlier when we were talking about the Nexus repositories. We're going to look at the settings.xml file shortly when we get to the step for uploading to Nexus. This part right here means that it's not going to run the tests. We have a separate stage for that. Post and success here mean that if the build step was completed, we want to archive and save the WAR file so it can be downloaded from the Jenkins dashboard. And this is our stage where we run the tests. After that, we have the Sonar analysis stage. In this step, we use the with SonarQube env plugin to perform the code analysis. This is found in the documentation for SonarQube. Here's the documentation that we use for that part. It basically has a few examples for whether you're using Sonar Scanner for Gradle, for Maven, or for .NET. Next, we have the quality gate step. The purpose of this stage is to wait for the results to come back from the previous step. And as we specified here, we're going to wait for up to 1 hour. Setting the parameter abort pipeline to true is going to abort the pipeline if the quality gate fails. Next, we have the stage where we upload the WAR file to our Nexus server. So in order for everything to work out when we upload to the Nexus repo, we must make sure that our pom.xml file has the right configurations, and we must have a settings.xml file as well. Let's take a look at those two files. Here we have our pom.xml file, and over here we have our settings.xml file. This article is very helpful in explaining what exactly we need to do in these two files. As you can see, it gives us an idea of what Nexus is used for and how to create the repositories that we created earlier. If we scroll down to this section right here, it'll tell us what exactly we need in our settings.xml file and what we need in our pom.xml file. So back to our pom.xml file. Let's scroll down, and here we have repositories. We're using the group repo, and we are injecting the Nexus IP and the Nexus port coming in from the Jenkins environment variables. And for the settings.xml, we have all 4 of our repositories here, and these names are coming in from the Jenkins file as well. And here for the mirror section, we're specifying the repository that we want to use. So we're using the group repo here and the IP and the port as well. Now we need to have a settings.xml file if we're going to push, or if we're going to publish our artifact to Nexus. Now back to our stage for Nexus. As you can see, we have a few things that we need. We have a Nexus artifact uploader, and this is from the Jenkins documentations for Nexus. You can refer to this documentation right here if you want to know how to implement that. So this is pretty much where we got this from. Now here we're going to use Nexus URL, which is our private IP of Nexus, and the port. And let's go up here and set the Nexus IP. Here we need to specify the private IP of our Nexus instance. As we said previously, since they're all in the same VPC, they can connect with one another via the private IP. Now the build timestamp over here is the exact same build timestamp that we were configuring earlier on the Jenkins dashboard. So here is where we're going to be using it, and it's going to be part of our system in which we label each artifact. So every time we upload the artifact, we want to distinguish it from the previous ones. So this is how we do it. And the build timestamp, as we saw earlier, has the year, the month, day, and time, and the time zone as well. So the next stage and the final stage is to deploy our artifact using Ansible Playbooks. So before we break this down any further, we need to do 2 things. First, let's look at how Ansible works exactly and what it's used for. And second, let's break down the Ansible Playbooks, or the YAML files that we're going to be using. After that, we're going to come back to this step, and this should make a lot more sense. So basically, Ansible allows you to automate a lot of tasks. Let's say you have a group of virtual machines with different operating systems and distributions that you want to provision. You want to update the package manager, for example, whether it's apt or yum based on the distribution. or install MySQL, Git, and do a lot of other cool tasks. With Ansible, you won't have to go into the terminal of every one of these virtual machines and manually run these commands. Instead, you first establish a connection between your master node and the servers you want to provision. And then from inside the Ansible server, you run a YAML file called a playbook, which has all of the tasks that you want to run on those servers. The next thing we need to do is to set up our Ansible credentials inside the Jenkins website so that we can use them in the Jenkinsfile later on. Since Ansible is running inside the Jenkins server, we need to establish an SSH connection between Jenkins and our app server. We need to copy the public key we generated inside Jenkins machine earlier and paste it into the server running the Java application. So we're going to need to SSH into the Jenkins server first. So we're here inside of the Jenkins server. Now let's SSH into the app server. We're going to go on git bash for that. Let's copy the public key and paste it into the authorized keys file here of the app server. So now let's go to the Jenkins dashboard. Let's click on Manage Jenkins, Credentials, Add credentials. Let's say SSH with private key. So for ID and description, we're going to write Ansible login. Username, we're going to say Ubuntu. Here we're going to paste the private key of our Jenkins server. So let's go here and create. And now we have a credential for Ansible. Next, we need to go inside of the Jenkins EC2 server and install Ansible. Now we need to install the Ansible plugin. Let's go to Manage Jenkins, Plugins, Available Plugins, search for Ansible, install without restart. Now, when Ansible deploys our latest artifacts to our EC2 app server, it's going to need the IP address or the domain name of the app server. We need to create an internal DNS record for our server running the app. The domain name will be used in the Ansible Playbooks during the deployment. So let's go to Route 53 and set this up. Hosted zones, create hosted zone. Let's call it bookworld.com. Make it a private hosted zone. US East 2. Our default VPC. Create. Now we need to create a record. We need to type www.bookworld.com here. This is going to be an A record. Now here we need to type the private IP address of our app server. Let's go get that. Here is the private IP. Create record. Now when you're using Ansible, there's a few things that you need. Let's look inside of our Ansible folder right here. This CFG file is basically where you specify all the configurations that you want. And for us, we just want to have the Ansible host key checking as false, because we don't want Ansible to get stopped for any reason during the SSH attempt. The inventory file is basically where we specify the DNS or the private IP. And since we just created a private hosted zone and an A name, we specify the A name, so it can refer to the app server as Bookworld instead of its private IP. We have a Bookworld YAML file, which is basically going to deploy the artifact, and we have a Tomcat YAML file here, which is going to set up Tomcat for us. And then the import YAML file is going to import both of those YAML files. And don't worry, we're going to go through these YAML files one by one. And the templates are going to come up pretty much when we're explaining what the Bookworld YAML file is. So let's take a look at the Tomcat YAML file. So the purpose of this playbook is to basically set up Tomcat for us on our app server every time we deploy. In Ansible, everything is done in blocks, and the first block starts under the tasks section right here. The first task is going to install Java. We will use the apt module, which is followed by the name of the package that we want to install. The state present is optional, so you don't need this if you're installing. But if you want to remove a package, then the state has to be absent. Here we're going to install Tomcat from the link we saw over here. The destination to download this package is in this folder. This folder will contain the zipped Tomcat files. We are going to unzip this folder and send the files inside of it to another directory, as we will see shortly. Next, we want to add a group for Tomcat using the group module, and we will add a Tomcat user using the user model. The shell will be set to no login, which is the Linux way to refuse login as the Tomcat user. We will also set the home directory as /user/local/tomcat8. This will be where the important folders are going to be, such as the root folder. Here we're going to use the file module to create this directory. We will see in a minute what it's for. Here we will unzip and place the files in the /temp/tomcat8 folder. When we run this task, an unzipped folder is going to be created and it's going to have a name. And we don't know what that name will be exactly. We're going to need the name of that folder in the synchronize step in a little bit. We will set the list files to true so that the files in the extracted folder could be listed when this task is run. From this list, we could capture the name of the extracted or unarchived folder. In Ansible, when we want to create a variable for later use, we register it. That's why we have the register unarchive_info here. We will use it to capture the name, as we will see shortly. Lastly, according to the Ansible docs, we must add the remote_source yes in order to unpack the archives that already exist on the target server. Now the debug module will be used to print a customized message after the previous task is run. We use the variable we created or registered in the previous task. Remember, we set list files to true. Because of this, the unarchive module will return a value called files, which is a list of the files inside the extracted folder. To be specific, the path of these files will be listed. At the beginning of the path is the name of the folder we want. We will get the first object from this list of paths, hence the 0. We want to split the name of the folder out, so we have to extract the name before the first /. So that's why we have the other 0 over here. And that's how we get the name of our folder that we're looking for. If this is confusing, please go back to the section where I broke down the Nexus installation script. Skip to the part where we use the tar command. You will find more clarity there. Here we're going to sync between these two folders. This is like the rsync command, which copies from one folder to another, but only copies files that have been changed. So it's more efficient than a copy command. We want to copy the contents of the extracted or unzipped folder to /user/local/tomcat8. We use the delegate_to directive because if we don't use it, Ansible will assume that the source is the master node. So it's going to look for the temp/tomcat8 inside of the server running this playbook, which is our Jenkins server, but we don't want that. We want the files to be copied from and to the server running Tomcat. The name of that server is located in the inventory file, as we spoke about earlier. This module will change the ownership of the Tomcat8 folder to the Tomcat user we created earlier. To understand this step, you need to know that when we install Tomcat, we need to create a tomcat.service file that has some configurations such as how the service will be started and stopped. This module will take the service file that we saved in this directory and paste it into the destination. So the file is actually this file over here. This is the file. The mode will set the permissions for this file, which makes it executable for everyone. The A is for all users, the plus is to grant or give, and the X is executable. Here we're going to reload the systemd to pick up the changes in the service file we made in the previous step. And then we're going to start and enable Tomcat server. Let's take a look at our second playbook. Here we will deploy the war file using this Ansible playbook. Like I said before, if you are familiar with how to manually deploy war files and set up Tomcat server, then this shouldn't be too difficult for you to grasp. Here we have our backup timestamp in case anything goes wrong, and we are going to use it in the coming steps, as you're going to see shortly. Here we're going to download the most recent war file from Nexus. For this URL, all of these variables are coming in from our Jenkins file. They're all coming in from this section of our Jenkins file. Here we have the stat module, which behaves as the stat command in Linux, which lists information about the specific file or directory, such as the size, the access permissions, the user ID, group ID, etc. We're going to register this as artifact_stat. As mentioned before, we register certain blocks when we need to perform another task later on that depends on this specific block. Now, in order to deploy the new war file, we're going to need to remove the old one and replace it with the new one that we got from Nexus. This all needs to happen while Tomcat is stopped. The service module is Ansible's way of running commands like systemctl. Here we need to understand some logic. Everything inside block is going to be executed, but in case of an error, we don't want Ansible to stop running the playbook, so the rescue will be run, and that rescue is all the way down here. Now inside of this block and rescue, we have another block and rescue, this one over here. Now the first block is going to attempt to do a few things. It's going to archive the war file using the archive module. This block is only going to run if latest_artifact exists. And this was latest_artifact. This is where we registered it earlier. Basically, we won't be archiving the old war file unless the new one exists. Then we're going to copy everything in the current root directory to another directory and call it old root. This is just another means of backing up the files for the last deployment and keeping them somewhere in case this new deployment goes bad and we need them again. The chdir specifies from where we want to run this copy command. Then we're going to remove the old war file using the file module. The with_item section will specify all the files that need to be deleted if you have more than one file. This block will only run if the archive_info has been changed, meaning it will run if the block where we archived the old war file was executed. The idea here is that we don't want to remove the old war file unless we archive it first. After that, we're going to try to deploy the artifact, or else it's going to restore the previous one from the old_root directory. We're going to try to deploy the artifact. Now, if there are any errors that occur before this specific block right here, i.e. before we delete the current artifact, then this rescue block is going to run, and the Tomcat service is going to be restarted, and the same war file will be running as before the Ansible playbook execution began. If any errors occur after this block right here, we're going to have this block and rescue working. Basically, if anything happens or if anything goes wrong while we're trying to deploy the new artifact, we're going to be rescued by this block right here, which is basically going to take the old_root directory where we put our old war file, and then it's going to jump to this step right here, and Tomcat is going to be restarted, and when it turns on again, we're going to have our old war file. However, if the deployment is successful, meaning if this step right here, deploy the artifact, is successful, we're going to register deploy_info. Once this is registered, this is going to be marked as changed, which means that this step is going to run if our deployment is successful. Here we have the wait_for module, which is basically a timeout that will put the server to sleep until the root file is present. Since we deleted the old root file, the new root file creation means that the deployment is happening. And here we're just going to restart Tomcat, and that is the end of our deployment. Now that we know how Ansible works and what the playbooks are doing, we're ready to look at this final stage of our CICD pipeline. Now we can get this from the documentations over here, and it does a good job of explaining how we use these plugins. So you can come here and copy and paste it based on your specifications. So here we have the inventory file as we saw earlier, and we have the import.yaml file. All the import.yaml file is doing is that it's taking the two playbooks that we just went over, the Tomcat playbook, which is used to set up the Tomcat server and the Tomcat service, and the bookworld.yaml playbook. And then we have the disable host checking, and then credentials from the environment variables up here, Ansible login. And then we have these extra variables that we spoke about, that we saw inside of the bookworld playbook, that we saw inside of this playbook right here. So all of these variables, as we mentioned earlier, are coming from here. So now we are ready to run this Jenkins file. What we're going to do is we're going to push to our master branch on GitHub, and then hopefully this will trigger the CICD. Let's check out the Jenkins dashboard now. Now I want to point you to a mistake that I made earlier. Over here we had Sonar Scanner, but it's really SonarQube, so make sure to fix that. Also, when we were setting up our pipeline, we need to make sure that we actually select a way in which our CICD is triggered. So we want to come down here and we want to choose this one right here, apply, and save. And let's go make an edit to our file, just a useless white space, for example. And hopefully this will start running automatically. Okay, the job is started. Now let's take a look at the console output. This might take a minute or two, and if there are any errors, we're going to see it from here. So it looks like the build step was successful. Okay, it looks like there is a failure somewhere. Let's see where it is. It says expected URL scheme HTTP or HTTPS, but no colon was found. It looks like the issue is over here. It looks like we have to specify HTTP : / and then we can apply and save. Let's go back to our pipeline. Let's create another commit. Let's look at the output. Okay, so this CICD job, or this CICD run completed successfully. Let's look over here, and here it is. It's job number 4, completed successfully. So this is what our app looks like right now. So let's go ahead and pretend that we're going to update something in our application, perhaps change something over here. Let's go to our VS Code. Let's go change some things here. Let's go to our API, source, main. Sorry, let's say hello, my friend. Yep, there it is. And then let's go to our test. And have the same thing here. Hello, my friend. Okay. So we're going to push it. And we're going to look at the console output again. Hopefully it should pass. And when it goes through the CICD successfully, we should see our change here automatically. So we're just going to observe from here. We can look at the console if we like, or this time we're going to observe from over here. Now, since we're getting our dependencies from the Nexus repository, it doesn't need to go to the external servers. It only needs to go to what we cached in our Nexus repository. So every time we run our CICDs, it shouldn't take as long as the first time. Okay, it looks like it's almost done. Okay, let's look at our app after it's done. Okay, it looks like it completed successfully. Let's look at our app. Okay, it should say hello, my friend, once we refresh. Give it a second. And here we are. Hello, my friend. Okay, so looks like our CI/CD pipeline is working successfully, doing exactly what it's supposed to be doing. I hope you learned something new in this video. It was a lot of steps to go through. Hopefully I simplified many of those steps for you. Be sure to come here and make sure you get rid of all of these instances so that you are not going to be charged. Hopefully you learned a lot. Thanks for watching. Stay tuned for the next video.